Apologies. How about now? Can you guys see my screen? You should be able to see my screen now. I just started it. All right, wonderful. Welcome everybody to Advanced Data Transformation in SQL workshop. In this workshop, we will go over advanced SQL concepts, mostly Windows, CTEs, and common query template patterns. So let's get started. If you have not done already, please go to the link in the description below. It'll take you to the GitHub repository. So once you're in the GitHub repository, so there are two ways you can set up and run along. One is through GitHub Codespaces, which is what I recommend. Super easy to set up. The other one is using Jupyter Notebooks locally. So you'll have to clone the repository, set up a virtual environment, install the requirements, and run Jupyter Lab. For this workshop, I'm going to assume we are going to run with Codespaces. So if you go ahead and click on this link, it'll ask for a prompt to create Codespaces. What this does is actually clone the repository into your account and start a Codespaces on that cloned repository. So go ahead and click on create Codespaces there. You have free tier, so that should be fine for a bit. And what GitHub will do is it'll look for the requirements.txt file and it'll start installing the necessary components. So that'll take about 5 minutes. And once that is done, we will run a setup command. But while we wait for the setup to complete, I'll quickly go over the format of this workshop. So the first thing is the data model that we are going to use in the workshop. So the data we are going to use in this workshop is called TPCH data, which is a common data set used for benchmarking database performances. It represents a car part sellers data warehouse structure. So you have orders, which is basically what customers buy from suppliers, and you have a line item which make up orders. Basically, an order can have one or more line item. It has additional information such as nation and region, but for this specific workshop, we will mostly just be working with line item and orders. Yes, Robert, Codespaces is free. All right. So that's the data model, right? And the concept here is we will learn about Windows and CTEs and common query templates, but there is a way we will learn this. So how this will generally go is first I'll talk about the why, like why do we even need window functions, for example, and then we will talk about the how, and then we will see an example with code which is runnable and I recommend you run it along with me. And finally, we will take some time to go over some exercises. So we'll do this for each individual topic in this workshop. So let's go ahead and open Codespaces. It's ready, I think. And first thing you will want to do is you'll want to do a setup.py. This essentially creates the data that we are going to be using throughout this workshop. Let me see. Okay, great. While that's creating, I'll go ahead and open the Windows concept first because that's what we are going to learn about first. So go ahead and open this concepts folder here, either in your GitHub Codespaces or in your local if you're running Jupyter Lab locally. And please open the Windows. And you will see it has two files, notebooks, specifically Windows and workshop solutions. Windows, it actually explains what Windows is and everything we will cover in this workshop. And the solutions are solutions to the exercise problems that we will go over in this notebook as well. As again, we'll have some time to do the workshop questions, exercises. However, if you can't complete them, that's totally fine. All this code is easily executable and available on GitHub, so you can clone it and do it at your own pace as well. All right. Any questions with the setup, or are we good to go? Let me see if there are any questions here. Okay, I guess there are no questions. Please let me know in the chat if you have any questions or if something is unclear. Okay, so if you go ahead and open this windows.ipython notebook, which is essentially a Jupyter notebook, this VS Code will open it in a Jupyter notebook extension, which already is installed for you. And the first 3 or first 4 cells are setup stuff. So essentially what we are saying is we are loading a SQL extension that allows us to run SQL queries inside Jupyter notebook. So go ahead and click that. Choose the Python environment. Don't choose an existing server or any code spaces, just choose Python environment. Choose the global one, which is Python 3.10.13. So let's go ahead and do that. So all this is doing is it's an extension that allows you to run SQL within Jupyter notebooks. And once that's done, we will go ahead and connect to a DuckDB database called tpch.db. DuckDB databases are essentially one file. So all the information is in that file. And we'll go ahead and run the simple configuration setting. Basically, if you run a select statement or anything without a limit, it'll limit it to 100 rows by default. Now let's go ahead and run this query to see if all the tables are available. And they seem to be. So are there any questions so far? Are we good? Great. So we have all the tables now. Now let's go ahead and start with window functions. Let me minimize this. And then a cool thing about running Jupyter Notebook is that you can see the outline and you can traverse it easily by clicking on it. So as I mentioned before, we will see a what, we will see the why, we will see the how. And that makes sense from an understanding perspective, because you need to understand what is this, for example, what does window function even mean before you think about how to implement it or why to implement it. And you'll have these different topics throughout the this notebook, so you can easily kind of traverse there as you need to. All right, so now let's start with the what. What does window functions even mean, and why do we need it? So in order to better understand the need for window functions, we need to start with group bys. So this is an example of a typical group by. So you sum by total price and you group by date. Essentially, you're grouping by 4 rows. Each, 7-8 has 4 rows, 7-9 has 3 rows, 7-10 has 3, and 7-11 has 1 row. And when you group by that, you typically run some sort of aggregation functions such as min, max, sum, average, or count. So in this case, we are summing total price. So we are getting an output data set, which is at a date level. So this is the key thing with group by, is that it changes the grain, or it changes what each row in the data set represents. In the input, each row represents one single order. So you have 4 orders on 7-8, 3 orders on 7-9, 3 on 7-10, and 1 on 7-11. However, in the output, you only have 1 row per date. So that's what people mean when they say by level or granularity. So we are taking an order level table, meaning 1 row per order, and converting it into a date level table. This is called change of grain. And group bys always result in change of grain, and it's very useful for looking at metrics over time, etc. Now let's take a look at window functions. When we think about window functions, an easy way to think about it is you want to operate similar to group by, which is you want to operate on a set of rows within a data set, and the set of rows is defined by 1 or more columns. However, you don't want to change the grain. You want to keep the same grain. Let's look at this simple example, right? So you have the same input data set. Data set is at an order level, And instead of doing group by, we do a window function. We just say sum of total price, partition by, not group by, and order by. So what happens is partition by defines the columns which will be used to define an individual partition within the data set. So in this case, the date is the partition. So these 4 partitions each have unique dates. And then the total price is the same, the order ID is the same. We are ordering by order ID within the partition. And then finally, if you look at the sum of total price, it's a little bit interesting because it calculates a running sum. What that means is sum of total price up to that current row. So if you consider the first row, the sum is just 100. The second row is the previous sum plus the current total price, 200. And then 200 plus 100 is 300, and 300 plus 100 is 400. However, when we go to the second partition or the next partition defined by unique values of dates, it restarts. So in a sense, you do get these values 400, 300, 300, and 100, but as the last kind of row within your partition. So window function allows you to keep the same granularity, whereas group bys changes granularity. So that is where window function comes from and the need for window function comes from. Okay, so what are the common scenarios why someone would want to use window functions? There are 3 main reasons someone would want to use window functions, and you can kind of suss out these reasons from the type of questions you get asked. If you have any question that requires running sum or sliding window aggregates, it's typically a window function based implementation. Or if you have some cases where you have to rank rows within a partition, that is again a window function. And finally, if you want to access other rows values, that is again a window function. So these 3, running metrics, sliding windows, ranking rows by some metric, or accessing values from other rows, are all window functions. And these 3 sections are called aggregate functions for sliding window functions or running metrics, ranking functions when you want to rank the rows within a partition, or value functions when you want to access other rows values. Okay, before we go to how we can create a window function, let me see if there are any questions here. Does anyone have any questions? Please let me know in the comment section. All right, doesn't seem to be. Okay, now let's think about how to create a window functions. Window functions, when you think about creating a window function, I recommend you think about it in 4 ways. The first one is partition, which defines how you can define a set of rows. So it can be 1 or more columns. We saw partition by date in the previous example. And then there's order by. So order by, what it does is it orders the rows inside a partition by the given columns. So it applies within the partition. And function is the function you want to apply to the rows. And window frames, which you'll see later in the workshop, it's a way to more granularly choose which rows you want to consider for computations inside a partition. So you have partition, and window frame is a way to choose the rows within a partition. It's a little bit more advanced. We will see it later as well. Now let's look at a simple window function. Same as before, we saw the partition by date, order by order ID, and summing the total price. So if you look at this, ideally you start with when you think about it, you want to start with a partition by, because that defines the set of rows within which you operate. So when you say partition by date, you'll have these 4 partitions because they are 4 unique dates: 7/8, 7/9, 7/10, and 7/11. And within each partition, you can order by order ID. So you can see it's ordered by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And note that the orders only apply within each partition. And then finally, the function, in our case, it's a sum, so it'll do a running sum. It'll consider the first row will be 100, then 100 plus 100, 200, then 100 plus 200, which will be 300, then 100 plus 300, which will be 400, and so on. One thing to note here is that partition by and order by are optional. What that means is if you don't define partition by, the entire data set will be considered a single partition. So if you want to do just a sliding window, you could just ignore partition by, the entire data set will be considered a single partition. Then there's the order by. You can ignore order by and it won't order the rows. The order of rows will not be guaranteed. However, this will make most of the functions meaningless, because if you do some sort of ranking, you definitely need an order by. If you do some sort of value, you need an order by to figure out which value to get the data from, which other row to get the data from. So typically you want an order by, but know that it is optional as well. Okay, let's go ahead and run this query, right? You can just press this run button, it'll just execute it. But let's go over it. So we have this orders table. Again, we'll see the schema below, but it's pretty straightforward. You have one row per order. So we are choosing the customer in the orders table, the order date, the price, the total price, and sum of total price. It's the same as here, but instead of partitioning by date, what we are doing is we are partitioning by customer key and ordering by order date. So let's think about what this means. This means within our data set, what we are partitioning by is customer key. Let's define it in English. Within our data set, for each customer, we are calculating the running total price starting from the earliest order date to the latest order date. That's what it means from an English perspective. The partition by is the customer key. So for each customer, when someone says for each, that typically means the partition by. And running sum is just the sum, and we are just ordering by the order date. So that is what this result is. And I just have this filter 4 here because customer 4 has a good use case. So you can see like they have so many records and so many orders. So the total price will be the same as running price, and then running price gets incrementally additive. Any questions so far? All right, so we have a couple of questions. Yes, Adam, the recording will be available on YouTube. I will also send out an email with this. Is possible use only the 3 rows of each groups? I'm not sure I understand your question, Christian. Could you please elaborate? I'll come back to your question later. How can we use row preceding? That's a good question, Divya. That's part of the window frame definition. We will come back to that in a later section. So if you see on the table of contents, you will see how to define a window frame. When we go over there, we will cover that as well. All right, so I'll keep going and I'll come back to that periodically. Right. Okay, so now what we have seen is an example of an aggregate function, a sum. So we saw sum being added, running sum. And typically when someone says aggregate functions, there are usually min, max, average, sum, and count. However, these days databases are extremely powerful and there are so many aggregate functions. For example, in DuckDB, they have multiple aggregate functions that you can check out. So my recommendation would be, whenever you're doing this, don't just assume you only have min, max, average, sum, and count. Always check your database documentation. These days database is extremely powerful, so there's a good chance that your use case is covered. Okay, now it's time for an exercise. The idea is you take some time to write code right now, so you kind of get a feel for how this works. Essentially, it's the same question as above, but instead of running sum, I want you to write a query to calculate the running average. I'll put 5 minutes on the clock. I'll be answering questions, but in 5 minutes I'll share the answers with you. Let's put 5 minutes on the clock. All right. That's great, Andy. By examine. Oh, I see what you mean, Christian. And yes, we can do that. So within a partition, we have option to select in rows. based on there are two ways. Again, we will cover this later in the workshop, because I don't want to kind of go back and forth between those two. And please let me know if anyone is having difficulty running this. Everything should work as is if you clone the repo or if you create a code spaces. Also, feel free to let me know if you're having any difficulty with writing queries as part of the exercise, and I'll help you out. Please let me know in the chat. Yeah, that's a good question, Adam. We can see the backend code of how max function is implemented. Depends on the database, obviously, but DuckDB is open source. So let's see if we can kind of go through that right now. So they will have it. They have it written in C++, so we might have to dig in there, but it's there. So if you go to DuckDB, and you can see this for any open source databases. So you go to source usually. To core functions, let's see, it should be an aggregate function. So if you go here, algebraic, average, sorry, did you say sum? Oh, you wanted max? All right, let's see. There is sum here. Where would be max? Is it in math? Let's see if it's math. Basically, we'll have to go through the code to understand how max is implemented. I haven't gone through this repository before, so I can't give you a easy answer right now, or a straight answer right now, but it's in there somewhere. We just have to figure out where. Does that answer your question, Adam? Great. All right, we are almost approaching end of time for this exercise. Please let me know if anyone is having any difficulties, or we will continue on to the next section. All right, so let's go on. And before we go here, and if you haven't completed it, that's totally fine. Again, if you go through the concepts, in this case Windows, and you click on Workshop Solutions, the answer is right here. So it's essentially just average. Please feel free to take a look at that. You can run it on your own time. And this 5 minutes is just, it's not like a lead code type thing. It's just a way to keep the workshop on track. So it's totally fine if you don't complete it. All right, so now let's go to the next section. So we saw how we can do running aggregates, running sum, running average. These are all numerical functions. Basically, they work on numerical data to produce some sort of metric. However, there is the second reason as to why we want to use a window function is to rank rows. So if you remember here, we saw why. The first one is calculating running metrics. The next one is ranking rows. So let's go over what the ranking rows actually means. Let's look at a very typical example, right? Let's say you have this orders table. It's 1 row per order. You have order ID, customer key, what's the order status, how much they paid, what the date was, and some other metrics, or sorry, some other attributes. And let's say the question is, we want to get the top 3 spending customers per day. So if you were to do this in group by, you will have, it's going to be tough because you'll have to do a subjoin. However, what they're asking here is a really good fit for window functions, because we want top 3 spending customers per day. Let's think about what that means. Per day is the partition. So per day, we want 3 customers and top 3 spenders. So you already have a clue of your partition, which is day. Top 3, which is your order, top 3 spending, so order by total price in descending order. And then top 3 represents your ranking of some sort. So you can use something called a rank function. So let's look at the code here, right? These are just, date and price and customer key. But let's look at the partition by. Per day translates to partition by order date. And top 3 by spend translates to order by total price descending. So you can see how you go from English to window function. Per day is partition, top 3 spending defines the order, and then all we have to do is rank the rows. So essentially we are ranking rows, and we have to put this in a subquery, so we can say where rank less than or equal to 3, because we only wanted the top 3. So let's go ahead and run this. So you can see here, this customer, this is for different customers, but for the same date, you can see here 92 1 they have these 3 customers are the top 3 spenders, and you have the same for 1 2 and so on and so forth. So you can see how you go from English to window function. Typically it will be top 3 spending customers per day. The top and spending represents the type of function, and spending represents the order. Per day represents the partition. So that's how you can easily kind of go from English to window functions. We have another exercise again, pretty similar. Instead of top 3, I want you to write a query to get the 3 lowest spending customers per day. Again, take 5 minutes. You don't have to complete it, and the solution is there, but it's recommended that you just try it out right now, so you kind of get an idea of how this works, and when you try it out at home, it becomes more natural and easier. I'll put 5 minutes on the clock, and I'll answer any questions. So Amit, for maximum per day, we could do one of 2 things. One, we could just do a group by and get the max. The other thing is you could just do a rank equal to 1, because the first rank represents the highest spender, and so on and so forth. Does that answer your question, Amit? Yeah, and qualify, it's a good point. I don't think qualify is available in every database. So in Snowflake, I know it's available. I'm not sure if it's available in every database. That's why we use the subquery. But that's a good point. So everyone basically, qualify is a way to do a filter on a window function without using a subquery or CTEs. That's a good point, Andy. Is anyone having please let me know if anyone has difficulty executing code, or either locally or on code spaces. I'll try to help out here. If we can take it out. So please let me know if you are done with the exercise problem as well. It'll help me to kind of know when to move on instead of giving extra time for this. That's great. Okay, I think that's enough. Again, it's not a big deal if you don't do it right now. Please take the time to go over it in your own time. It's not like a lead code type time thing. So, all right. So we looked at the ranking functions, but if you note here, we use something called rank. There are two more ranking functions that we should know. So they are dense rank and row number. They might seem similar, but they're a little bit different. So rank, obviously it will rank from 1 to n within the window frame. In our case, we don't have a window frame, so it'll be the partition. However, if two values are the same, it will skip the next rank. So if you have two ones, it'll skip 2 and go to rank number 3. However, with dense rank, even if you have same values, let's say you have two values, top values being the same, it'll rank them 1, 1, and the third one will be ranked 2. Row number is completely different. It does not consider the value of the column defined by the order by clause. It'll just numbers the rows from 1 to n. So let's go ahead and look at this example. Again, this is a super simple example where I'm just creating some fake data, and we are looking at row number, rank, and dense rank. Partition by date. So if you look at this, right, let's say 7, 8, you have row numbers 1 through 7. It doesn't consider the values even when they're the same. It just numbers them 1 through 7. And rank, you can see it numbers the same values, same rank. So you can see 90 and 90 will be 1 and 1. And then it skips 2, and it numbers these 300s as 333. And it'll skip 4 and 5 because you have 4 and 5 made up here. It'll go to 6 and 7. However, dense rank is a little bit different. It'll rank the same values of order by total price, right? It'll rank them as the same. However, it won't skip ranks. So it's from the name. It's just dense, meaning no skip. So that's what it means. And rank will by default skip. And row numbers do not skip at all. It just doesn't consider the value in the order by clause. Okay. We have seen two types of window functions, the aggregate ones, the ranking ones, and finally there's the value ones. If you remember, value functions are used to access other rows' values while operating on the current row. So let's look at a simple picture that kind of explains this, right? Same kind of data set. We are partitioning by date, ordering by order ID, and we can define this thing called lag total price, meaning it look for a lagging row, the previous row. So essentially what's happening here is this previous total price column, it'll look for the previous row, but there is no previous row. This is the start of the partition. So it'll be null, and then it'll be 100 because previous row is 100, 200 because previous row is 200, 150 because previous row is 150, and so on. The other thing is lead, which will look for the following, the next row. So it's obviously the first row is 100, but the next row is 200, and then it's 150, and then it's 90. So it's just looking for the next row. However, note that it does not cross the partition boundaries. And if you have window frame, it won't cross that boundary. It will just say null because there's no rows beyond that partition. Another thing to note here is by default, lead and lag will look at previous one row and following one row. However, you have an additional parameter here. So if you say lag total price comma 2, it will look for the two rows, the two rows before the current row. So if you consider this row 150, right, and you say lag 2, it'll actually get 10. And same with lead. You can actually say lead total price comma n or some number, which means it'll look at that row ahead of the current row. So that's lead and lag, and this is very helpful when you want to compare values across rows. Okay, let's go ahead and do another exercise where I want you to write a SQL query that from the orders uses the orders table alone to get order date, customer key, total price, which are columns directly from the orders table. And I want you to use lag to create a column called total price difference, which was today's total price, or this order's total price minus that customer's most recent previous order. So what that would mean is for each customer, you need to order by order date and consider the current total price minus the previous total price. That'll give you the total price difference. I'm gonna go ahead and put like 5 minutes on the clock. Please take the time to write the query. Again, it's not a big deal if you don't complete it. All the answers are here in the solutions workbook right here, so you can just use that as well if you want to try it out. And for the definition, it's similar to sum and ranking, the same format, function, over, partition by, order by. So that should be relatively straightforward. Please let me know if you have any questions or if you're stuck on anything. Yes, Amit, that's basically it. You can order by ascending and find the lowest 3 ranks. Please let me know if anyone is having difficulty with the code execution, or if you're done with this exercise, I'll go ahead and move on to the next one. Is anyone stuck with the exercise problem, or does anyone have any problems with that? We do need to consider order date because the total price difference definition is that the customer's current purchase minus the most recent previous purchase. That means you need to order by order date and you need to figure out what was the current price they spent minus the most recent price they spent. So if you order by ascending, that'll give you that. Okay, let's actually look at this exercise and look at the results for this exercise, right? So here you can see we are considering total price minus lag of total price. So what that will do is it will get today's price, or this purchase's price, or this order's price, and then it'll subtract previous order's price for each customer, which is partitioned by customer key. And we are ordering by order date. By default, it's ascending, so you'll go with the most earliest one, then and so on. So when you consider the current order date, we are considering the one that likely came before the current order. So this will give you the total price difference. Again, it's not a big deal if you didn't complete this. You can always try it out at your own time. All this is available online. Let's look at a quick reference of standard value functions. We saw lead and lag. There is first value and last value that gives the first value within a window frame and last value within a window frame. And then there's n-tile, which is basically bucketing. You can bucket the rows within your window frame into n buckets, and that's especially helpful when you do some sort of histogram type analytics. So there is that as well. All right, so now we come to the window frame. So up until now, we have operated on partition, but within a partition, a window frame allows us to kind of have some more flexibility in the number of rows we choose. So for example, in this picture, right, you can see we are partitioning by date. However, within the partition, we are kind of having a window of 3 order average. So you can see 100, 50, 50, 100 plus 50 plus 50 divided by 3 is 66.67. However, note that when we have the sliding window, it does not cross the partition boundaries. So in this second example, you can see that it will not cross into the next boundary. It will only consider 2 instead of 3. However, it will still divide by 3. So 10 plus 20. Yeah. So that's how this works. It will consider, you can define the sliding window within that. I think there's some sort of number error here. This should be 10. I'll take a look at that later. So let's consider why one might want to do this. This is typically useful when you are analyzing patterns over time and you typically want to move a window over your performance metrics, whatever that might be. In this example, we are averaging sales amount per store by date, right? It's per store. How is the sales performance? However, we are looking at the previous 2 days and current day. So that's what this definition does. It says rows between 2 preceding and current row. So it uses the sale day order to identify what the previous 2 rows are and what the current row is. And because we are ordering by sale date, you can know that the previous 2 days, whatever day that might be, will be considered, and the current day will be considered. So let's dig into how to define window frames. There are 2 main ways. The first one is using something called rows. Let's take a look at what that means. Take a look at this picture, and let's assume the current row that is being calculated is this order number 4. Everything above it within a partition will be considered preceding, and everything after it within a partition will be considered following. And you can see that if you say 1 preceding, it will just choose 1 row before the current row. If you say 2 preceding, it will choose 2 rows before the current row. If you say 3 preceding, it will choose 3 rows before the current row. And if you just say unbounded preceding, it will choose every row up to the partition boundary from the current row. So if you say unbound preceding, it's like it considers the start of the partition boundary up to the current row. And similarly, you can do the same for following. You can say 1 following, 2 following, 3 are unbounded. So these are just like start and end points. So you can think of them as you need a start point and an end point. It can be any of these. It can be unbounded preceding to unbounded following. That'll mean it's the entire partition every time. Or it can be 2 preceding to 2 following, meaning it'll be a 5-row selection, 1, 2, 3, 4, 5 every time, and you can think of them as just a sliding window. Surprisingly, you could also do 1 following and 2 following. That'll mean it's just considers the 2 row ahead of the current row to calculate some value for the current row. So you need these start and end points, and you can play around with them depending on your use case. So let's look at an example, right? Let's write a query on the orders table to get the customer key, order month, total price for that month, and 3-month average. So 3-month average being previous month's total price to this month's total price and next month's total price added and divided by 3. How we would do this? 3-month average of total price for that customer. So you know that the partition key is going to be customer, and you need to order by order month, because that will define how you are selecting the rows. So you order by order month, and then you choose 1 preceding, which is previous, and 1 following. So this window defines 1 preceding, current, and 1 following. So that will be the 3-month average. So I calculate the order month with this subquery, and here is our main window function. All this does is it's averaging over partition by customer key, because we want for each customer, and we are ordering by order month, and we are saying this window frame is 1 month before current month and 1 month after. So that will be the average. So that's the 3-month total price average. Let's go ahead and run that. So you can see it'll consider like 9.5 and 9.6 and so on and so forth. It's just a simple example. Okay, this might seem straightforward, but there is a thing that's missing here. When we consider the 3-month average, if a customer did not purchase anything for January, purchase something on February, and purchase something in December of that year, it will consider February and December as part of the aggregate, because that's the data that's available. That's the problem with rows. It considers the relative positioning, not the positioning based on value of the order by columns. Let me see if there. So that's where range comes in. So a range is similar to rows, but instead of considering the relative positioning, it allows us to use date ranges. And when you use range, the order by column always has to be a date time or date time column. But you can use this to define ranges or define the window frame based on how far away in time that the current row is from the other row. So let's take a look, right? Let's say we want to do range 1 day preceding and 1 day following. So let's take a look at this. You're calculating average total price over partition by customer ID, order by date, and note the range. Instead of rows, we use range, and we say between interval 1 day preceding and 1 day following. What this will do is this will look for any rows that's 1 day before the current row, and any row that's 1 day following the current row. And again, the order by column has to be a date or daytime column for us to be able to define these intervals. So let's take a look at this green window frame, right? We see it's made on 7.2. We say range between 1 preceding, meaning it'll look for 7.1, that's there, 100, and it'll look for 7.3, that's there, 50. So add these 3, divide by 3, 66.67. Similarly, let's look at this blue window frame. If you consider 7.7, it will look for preceding, which is 7.6, but that row is not here, so it's basically null. And look for 7.8, that is there. So 200 plus 40 by 3, 80. So you can see how you can use a range to kind of define a flexible window frame based on actual time than just the relative positioning of rows. So when you see questions asking for 3-month average, but those 3 months have to be consecutive, this is what you do. You have to use range. All right, now I'd like you to take some time to kind of understand how to do this by writing the query. Same query as before, the ones right here, but in addition to 3-month average, I want you to write a window function, basically using range, that calculates consecutive 3-month total price average, and this is how you convert your order date into a date representing the first of the month, because we are doing 3-month average. So I'm gonna put like 5 minutes on the clock and take your time to do this. In the meantime, I'll see if anyone has any questions. Does anyone have any questions? Please let me know in the chat. I'll try to answer them. Can everyone execute their notebooks? If you're having any issues, please let me know as well. Thank you, Warak. I hope I'm pronouncing your name right. I don't have any interview prep materials at the moment, but I should hopefully put something together that kind of uses the step-by-step execution flow, which I think is very helpful when learning. But thank you for that. Any questions with the execution? Are there any problems running the queries, writing the queries, or is it easy? Do the SQL work in Postgres also? Most of them do. However, you might need to change some functions, especially the date functions. So it should be portable. I would just pop it into, say, ChatGPT and ask it like, hey, write this in Postgres, and that should be good to go. And if you do want to run Postgres, I do have some repositories, super easy to set up Postgres. Let me see if I can find that for you. I'm sorry, Robert, I don't have one on hand at the moment, but it should be relatively straightforward to set up Postgres and try this out. You might need to create the tables, so that's pretty much it. So Bhargav, thank you for, you're welcome, Bhargav. I'm fairly new to DuckDB. Yeah, I mostly use DuckDB for processing data, not so much for accessing data. So for example, if you use DBT with like not a lot of data volume, DuckDB would be a great fit. And if you use any sort of data pipelines that cost a lot of money, but you're actually not processing a lot of information, a lot of data, you could use DuckDB. I did recently do a DuckDB presentation at one of DuckDB's meetup, and I do have my stuff here, like my presentation, so I'll post that in the chat. Maybe you can take a look at that, and you can also see this guy. Okay, this one. This is my presentation. If you click on the slides.pdf, that should give you the why to use DuckDB, and this is an example of how to use DuckDB. No worries again, that's great. Parse error, syntax error at or near day. So it should be date, Divya. I think that's the error you're running into, would be my guess. So Divya, I would recommend you look at this workshop solution that has like the kind of syntax. But I think that's the key here. The syntax is it's a little bit tricky, but the idea I want you to take away from this is just how to use range. The syntax you can always look at some online stuff or ChatGPT, but please do take a look at the workshop solution. They should run. Mitul, what's the advantage of using DuckDB compared to SQLite? Oh, that's a good question. SQLite, in my it's more for OLTP type work. So for like storing and retrieving rows of data that are smaller, it does have some analytical capabilities, but DuckDB is built from ground up for analytics, and it's really efficient for large amounts of data. So for example, right, in this presentation, I was talking about DuckDB and how you could actually use that to kind of process like 400 GBs of data per day at about $700 per month. So that was this post on Reddit about how this person wanted to bring down their cost to $3,000 and $5,000 per month. And I did a rough calculation, did some experiments. Again, the link, I posted it in the chat. You can take a look at that. And you could kind of bring down the cost to 700 USD. Can you do this with SQLite? I'm not so sure, because SQLite is not really designed for analytics. DuckDB is designed for analytics. It's really works really well with Iceberg or S3 or Parquet type files. So that's why I think you should try it out. All right, I think we are at time. So again, it's not a big deal if you didn't complete this exercise. Solutions are there. Please try them out on your own time. I think you will only learn if you actually try it out and actually write code. So let's take a step back. So that's for window functions. So let's do a quick recap. We saw why window functions are there, because you want to keep the grain the same, but you want to do group by like calculations, right? That's the why. And when to use window function is calculating running metrics or sliding window type metrics, ranking rows, accessing other row values. So those are the when. So whenever a question comes up, hey, can we get the top 3 within this group, or get the bottom 3, or get the difference or addition of current row and previous row, that's when you have to use windows. And then we saw Windows has 4 parts: partition by, order by, which are both optional, function, which is again value function or aggregate function or ranking function, and finally window frame using rows and ranges. Rows defining window frame based on relative positioning, range defining window frame based on time ranges. And finally, this is not covered in this lesson, and I'll talk about it later, maybe later, but basically window functions are really expensive. It's super expensive because you're essentially scanning the entire data set. So unless you have to, don't use this at a user data access layer. Maybe you will probably end up using it in the transformation layer. However, don't try to limit the use of window function because they're really expensive. You can use it for debugging, etc. But if it's repeatedly used multiple times a day, you probably want to kind of think about it another way, model it better, because they are really expensive. Again, all the workshop solutions are here in this workshop solutions notebook. Another thing I do want you to remember is that this outline is really helpful. So you can just use this to figure out, hey, what are the common scenarios? So I want you to be able to use this as a reference, and don't worry about memorizing it. Just use it as a reference. This should give you some idea of how to approach most problems involving window functions. And the final thing is we are using DuckDB, as you know. The thing with DuckDB is that you can only use one access or one writer at a time. So if you're running this on VS Code, do a restart kernel, which means it will sever the connection to DuckDB. If you're on Jupyter Notebook locally, you could just click on File, or actually, where is that? Click on Kernel and shut down all kernels. That will just shut down everything that's running, because DuckDB can only operate on one, can only have one writer at a time. So you need to do that. All right. Any questions with window functions? Thank you, Mitchell. Thank you, Andy. Do you guys need a break, or can we keep going? We have an hour left, so I would like to cover CTEs and query templates. And before that, do you have any questions with window functions? Do you have a mental model? Don't worry about the format, just a mental model of when to use window functions. What are the way to define window frames, and what are the 4 key components of window functions? If you take away anything from this presentation or this workshop, those are the main things I want you to take away, the recap, because you can always kind of come back and look at the format, but it's just the 4 key points that I want you to take away. Yeah, let's take a 5-minute break. It's been quite a while. Yeah, I'll put 5 minutes on the clock, and I'll come back and let you guys know when I'm back. Hey Shah, I just joined 1 minute ago. Can you tell me where I can? Sure. Go to this repository. And then click on sorry, 1 second. If you go to this repository and you click on this GitHub code spaces, it'll open up. Give it 5 minutes to set up the requirements and run python setup.py. Once you have that, you should we can just go to it'll open up a code spaces, and you can go to concepts and look at the Windows or CTEs. We already completed Windows, but it's going to be CTEs next. So yeah, welcome aboard. Thanks, Aaron. I appreciate that. Thank you. Just a reminder, we are on break. We'll be back in about 3 to 4 minutes. Please let me go. Please let me know if you have any questions. I'll be here the entire time. Do I think it affects job market? Do you mean? Are you asking me, Aaron, if Power BI is somehow changing the number of data analysts required, or are you asking me, is it a requirement for data analysts to know Power BI? If it's the latter, I would definitely say yes. And this is data backed. So if you go to this great website called datanerd.tech, you could see that, let's say data analyst, right? And Power BI is, where is this? Is it considered, a tool, right? Power BI is up there, right? It's one of the top 3. So you need to, I would just learn it a little bit and play around with it. There are some great tutorials online as well. But ideally what I would recommend you do is just know what that is, take some data, whatever it might be, and make some sort of try it out, build a dashboard, and just publish it if you can, or take a screenshot and put it on GitHub, so people know that you actually know that. Does that help, Aaron? Thank you. Yeah, sure, Shah. Like your username. Let's see. I'm assuming it's the Shah checksum. I'll come back to you, Aaron. Let me just quickly recap this. Shah, if you're just joining, there's this great thing about about Jupyter notebooks. Even if you're running on Codespaces or locally, where you can just open up this notebook and you can actually see the table of contents, which is a really great way of doing it. So kind of going through revising stuff. So let's go over the recap. So yes, your question specifically was window function. Yeah. So window functions are used when you want to do a group by type operation, but you don't want to change the granularity. So what do I mean by that? So if you look at this example, group by changes granularity, meaning it changes what a row represents in a data set. So the input here is order level, meaning 1 row per order. But when you group by, it becomes group by date. It becomes date level, or 1 row per date. However, you can use window function to keep the same granularity and still do computations on a subset of rows defined by a certain column. So that's called partition. We are partitioning by date, and that's the partition by date clause in the window function definition. And you can see that the granularity is the same. So that's why window functions, that's the kind of mindset behind window function. And then that's why, and then when to use it is usually 3 key phrases to look for when someone is talking to you in English, and you pay mind to these 3 phrases. One is running metric or sliding window. And you still want to keep because those usually involve some sort of aggregations and still keeping the granularity the same. And the second one is ranking rows, and the final one is comparing current rows values to some other rows values. So those are the when. Again, we go over this in the notebook. Please feel free to take a look at that. And if you have any questions, let me know in the GitHub issues or reach out to me. And then finally, how to define it. It has 4 key parts: partition, order, function, window frame. A partition defines a group of rows within which the function will operate on, and order by defines the order of rows within that partition. And window frame is provides a more granular control. What that means is you can have a partition, and the window frame will define how many rows within that partition you want to consider as part of your function computation. And window frame can be defined using rows or ranges. I'm not going to go into detail now. I did cover it a bit earlier, but please go ahead and look at that. But that's essentially the idea. And the final thing is window functions are really, really expensive because they do full table scans, because you're just like running through the entire table. So be very careful about using it. You will typically end up using it in your transformation process, but if you're using it, or if your end users are using it for every time they query your database, that is probably not a great idea. And you want to do like something like pre-aggregation, or turning the results into a table so that they can just do a select star or something instead of doing window functions. So they're really expensive, but just be mindful of that, and that they are not over abused. So those are like the recap. I would recommend you go through this, because there's quite a bit with exercises and such. I hope that helps, Shah. So Aaron, you're struggling to decide what to focus on, SQL, Python, and new DB technologies, or Power BI. So Aaron, I would say if you're going for analyst, I would say SQL is topmost, and then Python. I wouldn't so much consider new DB technologies, because essentially everything, right? Spark or Snowflake or BigQuery, they are all OLAP. So there are like some common patterns there, like partitioning, bucketing, reducing data shuffle. That is the idea behind it. So I would start with SQL, like knowing window function. This is almost certainly that you'll be asked this in your interviews. And Python, knowing basic data structures, how to pull data, how to push data from like some APIs or from S3, and how to push data into APIs or S3 or your data warehouse. And Power BI, especially since you're going for an analyst position, you need to kind of understand the data. I do know that if you're an analyst, they give you like business problems, so you need to kind of be able to suss out what the data, understand what the data means, and how to get value out of that data. I wouldn't spend a lot of time going deep into the tech if you're trying to get into data as a data analyst. Yeah, you have to know most of it, but if you're going for the job market, especially in this job market, if you're trying to get a job, I would concentrate a lot on SQL and Python. And the OLAP DBs they are very efficient for full table scans, but the tables are also ginormous. Sometimes they are in terabytes, and if you are doing full table scans on like 12 terabytes or 10 terabytes, of course, OLAP DBs are going to be super efficient, but it's still pretty bad. And the worst part is you get charged by data use. So if you put this on Snowflake and you do window functions every time, they're going to charge you through the roof, because that's going to be a full table scan with each query, unless you have like some caching or whatnot. But let's just, for a simple case, for each query, if you do a full table scan on like a 10 terabyte database or table, it's gonna you're gonna go bankrupt or something. So please be careful with that. That would be my recommendation. All right, I think that's enough time for break. Let's go ahead, get on with CTEs. Again, if you remember, please restart this before coming to CTEs. Same stuff, we are loading some extensions to be able to run SQL. We are connecting to the database. We are setting limit to 100. We are checking that the tables are present. Great. So that means we are ready to go. CTE should be relatively straightforward. So the first one is why? What is CTE? Why do we need to use CTE? The main reason for CTEs is to improve readability and reduce code repetition. A CTE is essentially just a select statement, a named select statement, if you will. And what used to happen was there used to be these 1,000 or 100, 800 lines query that has multiple subqueries, and often these subqueries were repeated and very, very hard to read and hard to modify, because if you have repeated subqueries, you'll have to modify any changes in each of these places. Very manual, error prone, hard to test. CTEs make it easy, make your code easy to read, and if you have any changes, you just have to change in one place. So let's take a look at an example, right? So this is, let's kind of quickly recap on the data model here. So you have this data model, assume we are getting nation level metrics for suppliers and customers, and we are comparing them. That's essentially what we are doing here. So you use CTE, and CTE is easily defined using a with name of the CTE as, and inside this is essentially just a select statement. So I'm just doing a aggregate by nation key, some joins here, and now you have supplier nation metrics. And similarly, you can define a buyer nation matrix, which is the second CT. And finally, there can only be one select, kind of final select statement in this query. So you do select and you just join the two CTs. It just makes it easy to define your subqueries in such a way, because if I am someone who's new to the code base and I look at this, I can intuitively make sense of what this is trying to do. However, if you didn't name it right and you just put in this as an entire subquery here with the alias s, that's just going to be really difficult to read. And this is a simple example. This only has two CTEs. Typically, there are many CTEs, and that will make readability a problem. So let's go ahead and run this. This is simple kind of nation level metrics. Now I want you to take some time to write your own CTEs, but this is going to be a little bit tricky because you have orders table and line item. Remember, one order can have one or more line item, and you join them on order key. In the orders table, order key is the kind of primary key. In line item, the combination of order key and line number is the primary key. What happens is when you have multiple line items, each line item has certain amount of tags and certain discount associated with it, and they get computed appropriately and rolled up into total price. And this data is already there for us. But what I want you to do is I want you to get the sum of extended price at an order level from line item and compare it with total price, because I want to see what the impact of the discount was. So think about it in steps. So you're changing granularity. So group by for line item. So think of that as an individual CTE, and then join it with orders to compute or compare the cost difference between orders, total price, and sum of extended price from line item table, aggregated to an order level. I'll go ahead and put like 5 to 6 minutes on the clock. Again, the solutions are available in this workshop solutions notebook. You can always take a look at that if you get stuck. But I would like you to try to do this with CTEs. In the meantime, if you have any questions, please let me know in the comment section. Are you guys still trying, or should we keep going? All right, Jorge. Yeah, that's fine. I can take like a minute to answer that. Uh, it's a tricky one, right? Because I do know. I mean, I have tried this as well. I do know with Claude, I can quickly whip up a data pipeline in a matter of minutes. Like I don't have to write so much code. However, I still need to know the fundamental principles. I still need to know the design patterns. I still need to know how to design a pipeline given my constraints. So it's, to be honest, it's easy for seniors. It's tough for juniors, someone entering the field, because so much, not like juniors typically kind of do the coding, do the testing. That's how you learn, right? That's how I started learning. So it's kind of tough at this moment, especially for juniors. How I would stay competitive is depends on where you are. If you already have a job, I would spend a lot of time showing value. What that means, it could be like some presentation, kind of evangelizing what the work you've already done. But I would, if you're not new to the job market, I would try to do some projects that kind of succinctly explain the things you have done, the things you have considered. The main thing being networking. That's definitely going to be the difference, especially if you're new to the field. Go to meetups, talk to people. For example, I have recommended many people who talk to me in person, and I go to some meetups, right? Than someone just reaching out to me on LinkedIn saying, hey, find a job for me. So put a lot of effort into how you come off as, put a lot of effort into selling yourself. Basically, you want to show that if people do some little bit of work for you, you are going to give them a lot more. So with the referrals, right? Show them that if they take the time to refer you, you're going to get that job and you're going to make the money, because referrals usually get some thousands of dollars if the person they referred gets the job and stays at that company for a while. I hope that helps, Jorge. It's a big topic, but that's just like the gist of it. All right. Thanks, Andy. Let's keep going. So if you look at the solution here, right, it's essentially you're aggregating. It's a CTE to consider the line item aggregate. You just group by order key and aggregate extended price, and then you just join it with orders by order key and do the difference. That's what we consider amount lost to discount. All right, let's keep going. The next main thing is, while CTE sounds like a good idea, you should obviously be aware of the trade-offs. A SQL query with temporary tables individually defined is oftentimes much better than like 1,000 or even 3,000 line SQL query with so many CTEs that it gets hard to keep track of how many CTEs there are. I would typically keep the number of CTEs per query low. So for example, 5 is pushing it in my opinion, but again, it depends on your kind of company and the culture there, but I would typically keep it anything below 5. Let's do a quick case study type question, right? I want you guys to look at this query and answer this question. Let's say you have you build this giant query. How does this impact code reusability, and how would you change this code so that your colleagues or teammates can actually benefit from this stuff that you have already built? Please let me know in the comment section below. Or no, in the YouTube chat, I mean, sorry. Please let me know in the YouTube chat. How would you change this query so it's more reusable, and primarily what's wrong with this giant query? Just 1 or 2 sentences is fine too. Doesn't have to be a long-winded explanation. Mitchell, I would go to any meetup that is either held by a company. So for example, there's a lot of DuckDB meetups, and you can meet a lot of folks there. And also anything that is held by some sort of consulting people. So there's this meetup called Loki Data Meetup. I would go there just to kind of talk to people. Basically, if you see any group that's kind of technical but also may involve some management people, I would just go in there. I don't know any off the top of my head right now, unfortunately. Anywho, coming back to the exercise, does anyone have any comments on how this or what's wrong with this query? Does everyone think this is great or this query is good? I mean, wrong answers, if you don't know, that's fine too. Just whatever you think, just let me know if you can. Let's give a minute here. Okay, I think the main thing here in this giant query is that if you look at this query, you're creating a lot of tables that are actually reusable. So for example, customer dimension, that's a reusable table, and you don't want your code to be repeated elsewhere. You don't want this key code to be repeated elsewhere. So typically what you would do is you split this off into an individual table, and that's like what DBT will do, right? You split this off into individual tables. So when it comes to CTE, use it sparingly. Use it to make sure that it actually helps in readability of your code, and it doesn't, and make sure you're not recreating work that's based on table somewhere. And for example, if you're deriving a new column and adding it to a table as like a CTE implementation, think about it and see if that column actually makes sense in the base table, and you can actually add that add that column to the base table, meaning everyone in your team can now have access to that column. So the reusability versus readability is a kind of fine line you have to walk when you work with CTEs. That's what I would think about when you use CTEs. And again, make sure it's reusable by others, and you write CTEs to actually help with readability, and you're not creating a silo of information, if you will, with your CTE. Okay, let's recap what CTEs are. Again, CTEs are pretty straightforward. They're just select statements with specific names and can be only used in one query. And they help with readability and reusability of code. And they're defined with the with keyword. Don't overuse it. Be mindful of query size. Don't have like 800 or 1,000 line SQL queries with so many CTEs. Think about how you can model your data or your data pipeline better so that you're not writing these giant queries. And finally, we don't cover performance in this workshop, but maybe in a future one. The performance of CTEs are tricky because they are DB dependent. Sometimes some databases optimize CTE performance, meaning they compute them once and use them multiple times. Some DBs are not super smart, so they compute CTEs multiple times, and there are a lot of nuances in that. So I would use the query planner to see how CTEs are computed, because they are also heavy in performance sometimes. Again, solutions are available in the workshop solutions notebook. Please stop this kernel by clicking on the restart. Or if you are on Jupyter Notebook running locally, you can just click on this interrupt the kernel button, and it should be good. All right, so we went through Windows, went through CTEs. The final one is the query templates. All right, so similarly to before, we are starting loading the SQL extension, connecting to DuckDB, and setting the default limit to 100, and running this query to see if all the tables are loaded. Great. So in this section, I want to cover some common scenarios that I've seen so many times in my career across different industries, and that those are solvable using window functions and group bys. And this is super common that, like, no matter which industry you go, they always do these sort of things. So I want to go over those. But before that, Mitul has a question. By reusable, you mean within execution of particular query, or does it mean? By reusable, I mean execution as a benefit of CTE, it's execution within a particular query. But when you consider from a design perspective, you might want to move certain CTEs into actual tables, then it'll be reusable by other members of the team. I hope that makes sense. There's like two sense of reusability here. One is to make your single query easier to use, and the other one is if there's a lot of data silo, meaning you're doing a lot of computation inside your CTE that you think other team members may benefit from, you move that CTE into a table or a view that others can use. All right, so let's come back to this query template. So the first pattern or the first template that I've seen many places ask for is finding a nth event in a series of events. So what does that mean? That means, for example, if you're storing clickstream information, such as impressions, clicks, checkouts, etc., you want to figure out, like, let's say the 10th click in a series of clicks. So if you're on a website and you're clicking on 10 products, let's say I want to figure out what's the 5th product you clicked on. I can use this pattern to figure that out. This can also be used for something called attribution in marketing. Basically what that means is, let's say you go to some influencer website and they have an affiliate link usually, which comes with some parameters, usually called UTM parameters. And when you click on that, it takes you to the web page, but it lets the web page know, hey, this is the source that I'm coming from, so that the web page can actually pay the influencer the money, right? The attribution is typically what it's called. And if you have multiple clicks, you want to figure out when an attribution occurred. There are certain pricing models which require you to figure out if a user had already landed on that page before being redirected by some influencer web page, etc. So basically, when you want to see a series of events and figure out the nth event or last event or first event in a series of events, this is extremely helpful. So let's take I'll come back to you later, Amit. Let's take a look at this example, right? You want to find the nth click in a series of user clicks. This can be due to some attribution stuff that you need to do, or it can be due to some debugging. Let's look at this image, right? You have a user ID, you have click ID, you have click time, and you want to find the third click. So first of all, what is the third click? That just means by time, 10, 10:05, 10:10 is the third click, and user ID. So we are partitioning by a specific user. So let's look at this example. I use like a fake data here. What we are doing is we are ranking using row numbers, but we are ordering by click time, right? So it'll rank 1, 2, 3, 4, and then I'm just saying rank number 3. So it'll give us the third rank. In this case, it'll be this and this. So the third click of a user. And it might not seem like, hey, why do we even care about the third click? But it's helpful in debugging situations and in attribution type situations. This pattern can also be used to identify duplicate clicks or duplicate records. So by the same pattern, you can order by some time, and you can see that these two clicks happened on the same time. So maybe an issue happened on the front end where it generates duplicate clicks, and you have to now clean the data on your data warehouse side. How do you do this? Same pattern. You order by time, you number them by rows, and you can ignore them. But this is a little bit tricky because if you partition by user and you order by click time, you still would not know which one to remove. So you might have to think a little bit differently to approach this. And this is an exercise. We are running late on time, so I'm going to leave this as like a homework for you guys. But basically what we end up doing is, instead of partitioning by just user ID, we partition by user ID and click time, meaning this will be one, this will be one, these two will be 1 and 2. So take a look at the solutions, but please try them out at your own time, especially because we are running late on this. All right. The second pattern is converting rows to columns. If you have worked with Excel, this is very familiar. This should be very familiar to you. It's called pivoting. It's really common by business folks to kind of group by values and then pivot it, meaning convert certain rows to columns so that they can visually inspect the distribution. So this is what it would look like. Let's say you're grouping by month and order priority and computing total price or sum or average, right? You can see how the order priority values are converted into individual rows. And this kind of gives like an easier visual representation. So you see there are no urgent or high or medium orders during the month of 9202. So this is really helpful for visual inspection especially. And if you have ever worked with anyone using Excel, this is almost always what they do. They do a pivot and then they do a conditional formatting with like colors to make it easy to inspect. And this is a very common pattern in most data analytic pipelines usually, right? So let's take a step back and think about how we would do this in SQL. The one on the left side, it's pretty straightforward. You group by month, you group by order priority, and do a sum on total price. That will give you the total price for that month and that order priority. Now let's take a look at the image on the right. How do we get that, right? I want you to take some time to think about it. But note here that the value of 92, let's say 9202, not specific, is 58,749. The value is the same. It's just how it's displayed. So how would you go about doing this? Right hand side, getting the right hand side, and you know that the left hand side you can get by just grouping by order month and order priority. How would you think about getting the right hand side? Please let me know in the comments below. Okay, I'm gonna assume there is no answer here, so that's okay. Okay, that's fine. So how you would do this is, it's the same group by, but something called a conditional group by. So you still group by order month, but instead of grouping by order priority as well, what you do is you aggregate conditionally. So let's see what that means, right? Let's look at this. We are calculating average, but within that average, we are using a conditional statement, also known as case when. Oops, sorry. So for example, here, you're averaging values only if they're urgent, only if the priority is urgent. Otherwise, we are saying null, and we name it urgent order average price. And similarly, we do the same for high and medium and not specified and all. So this conditional aggregate, or conditions within an aggregate, is a way to kind of create this pivot table. So let's go ahead and run this. So you can see how it's split out our data into individual columns instead of rows. There's a lot of information here. But essentially the idea is you do a conditional aggregate instead of just an aggregate. So instead of having a order priority as another group by clause, you put it inside this average or sum or whatever you need it to be. But note that this is very repetitive. You have to do this over and over again. So it kind of gets tedious, especially if you have lots of columns to do this on. Again, since we are running late on time, I'm gonna skip this exercise. Please do this on your own time. The solutions are available, and some one thing I do want to note is some databases support pivot naturally, so they have built-in functionality to do pivots, and DuckDB does have pivot. For some reason, it does not work on Jupyter Notebook, but if you run it locally, it works. So try that out. And the final pattern is period over period comparisons. So when you look at any analytical data dashboards, like Google Analytics or even your inbuilt dashboards, you always see a way to choose a time period. So in this case, November to December, and you'll always see some of these big card type things, and they'll have some plus or minus percentages next to it. That represents period change percentage, period over period comparison, month over month, or year over year, or week over week, whatever it might be. These represents key information that end users always look for. Let's look at a more easy to understand example, at least for me. This is my website's analytics. So what they do is, there's this website called Plausible, privacy-friendly trackers. What they do is they allow you to choose the time period. So I've chosen month to date in this example. And what they show you is these different metrics: unique visitors, total visits, total page views, views per visit, blah, blah, blah. And they show you this change percentage: down by 19, down by 18, down by 17, up by 1, up by 1, up by 6. And this is a change percentage. And this is critical for end users, in this case me, because I need to see how my performance is doing. How is my website performing? Why is it going low? Is there anything I can do to change it? So these are critical numbers. These are called change metrics, period over period change metrics, and these are like common across any dashboards that people build for analytics. It's very important to do time over time period differences. And again, this pattern we can do with window functions. So let's take a step back. Let's remember the type of window functions. We went over aggregates, we went over values, we went over ranking. I want you to take some time to think about which of these three is a good fit here. Assume we have time period based metrics. Which one of these three, ranking, value, or aggregate function, should we use? Please let me know in the YouTube comments. Oh, I didn't know about that. Postgres does have some pretty cool stuff, Andy. Some filterware. That makes sense. Yeah, but it's the same pattern. You're grouping with the filter, so that's why I call it conditional filter. It's always some sort of conditional aggregate. Yeah. Okay. Does anyone know what type of window functions we need to use to get these period over period metrics? Is it aggregate, or is it value, or is it ranking? Yes, Aaron, you're right. It's value because we are comparing the current time period to previous time period. So that's exactly right. You're comparing the current row to previous. I don't think it's ranking, because ranking it's for is ranking the rows or ranking some metrics, but we are not ranking, we are comparing. So it's aggregates and values. Yes, we are first aggregating to get the numbers, so unique visitors, total visits, total page views, whatever it might be, and we are doing value to division with a lag. So that's great. So I think everyone gets it, so that's amazing. So I have a simple example here. You can see difference where we are computing revenue difference by the previous month's revenue. And similarly, we are dividing it just to get the percentage. So you can go ahead and run it. So what happens here is we are computing the aggregate. We are using group by. I mean, we can use windows, but group by is easier because we don't need any windows here. We are just aggregating by month. And then we are taking this month's revenue and comparing it with the previous month's revenue. That's what we are doing in both these metrics. And that's the metric comparison. And this is critical because any dashboard that involves some time period, anyone would like to see how things have changed. That gives a sense of performance. Hey, I'm doing okay, our data is doing well, our metrics are doing well, or our metrics are doing bad. What can I do to change? So that's like a key human thing people look for. You can use lead as well, depends on how you organize your data, but mostly it's just comparing to the previous. Usually mentally it makes more sense to lag previous, so previous changes lag. So here's the output. Again, I'm not gonna do this, but basically, let's say I don't think we have the time, but let's just say we have to design the data set required for this dashboard, right? How would you go about designing it? Because there are a couple of things to consider. One, you have to dynamically be able to change this filter. So I can kind of quickly show you how this will look like, right? This is my website, and you can see like they have so many time periods. So the data set that you design has to support all these time periods: yesterday, today, real time, 7 days, 30 days, month to day, all time, custom range. And just note that this is like super advanced dashboarding. I know this plausible uses like real-time analytics using ClickHouse, so that's why they're able to do real-time and a lot of advanced stuff. Most companies don't have all these options, so this is really advanced stuff, right? How do you design the underlying table or tables that you can use to create this sort of rich view? It's not straightforward. It's quite a bit. It's quite a bit of work. So some of the things I want you to consider are: how would you design your data model that supports this dashboard so you can see metrics at day, week, month, year levels? And what are the questions you would ask a dashboard team, right? Like, how would you collect requirements? And finally, what would your table look like? It's this pretty complex stuff, and honestly there is no right answer. It depends a lot on the database you're using, the front-end requirements, etc. So if you take a step back, there are some the answers are here as well. The answers are short, but basically it depends a lot on your individual scenario. But some of the things you want to consider are: firstly, query patterns. How many queries per second? Is someone going to be accessing this dashboard once a day, or twice a day, or thrice a day, or 10 times a second? What are the other filters? Is it just time period filters? Can we filter by some other metric, right? And then when you come to performance, what's the size of the data? If you aggregate the data with every query, it's going to cost a lot of money. How are we going to handle that? And then it comes to, can we pre-aggregate the data? How do we pre-aggregate the data so that the data is fresh? How do we aggregate metrics that are additive, like sum, count, versus metrics that are non-additive, like percentages, distinct count, etc. So those are the things you have to think about. Honestly, this is such a big topic, but I just wanted you to think about how dashboards are built, especially with these time-based comparisons. You can do them with window functions, but as we saw earlier, these are pretty expensive operations, and you need to ask these questions to the end user, or whoever is building the front end, or whoever knows the product, to be able to build a suitable data model that can solve this whatever need they have. So that's that. Dimensional model with a date table. Maybe, I'm assuming you mean like a wide table with a date table. Again, then comes the question of granularity, right? Will you keep it at individual click level? then how do you quickly aggregate for the past year? So for example here, right? So this information is at a click level because they track at our visitor level, they track every visitor, right? And if I say year to date, it takes less than a second, boom, it's there. How would you do it to be that good, right? Those are the types of things you need to think about. Honestly, there's no like straight answer here. It's more about working with what you have towards getting to or defining the end goal, clearly defining what the latency is, what the query per seconds are, and working towards getting there. All right, to recap, we saw 3 key patterns: nth event in a series of events, and also removing duplicates, pivoting in SQL, and period over period change calculations, and the impact of your data model, or how to think about your data model for building high performance dashboards. Again, I know we talked about this earlier, but window functions are super expensive. If your use case requires repeated use of them, you might want to consider pre-aggregating your data sets. Again, workshop solutions will be available right next to this, so you can open that up to look at the solutions. Remember to restart or shut down the kernel so you can restart it again. Take a look at this outline that can help you from a more understanding perspective. Again, you don't need to know the exact syntax. It's just more about understanding these things than knowing the exact syntax, at least for like real job. For if you're talking about interviews, that's a different thing, but from a real job perspective, this is how you approach it, right? Finally, next steps. So if you like kind of this sort of workshop type approach, I'm thinking of putting together like an end-to-end data engineering workshop, probably like intense 2-weekend or something, 6 to 8 hours a day or something like that, where I want to start from like Python, SQL, the underlying concepts, how to build data projects, how to host it on AWS. And finally, one thing I do want to talk about is building targeted data portfolios. So instead of just building another Uber car analytics or another NYC taxi analytics, I want you to think about what the employer is looking for and quickly put together a portfolio for a specific vertical employer. So for example, if you're targeting e-commerce, you put together clickstream analytics, or you put together performance analytics on orders data. If you're targeting insurance, you put together fraud analytics. If you're targeting, like music companies, you put together a portfolio demonstrating music artist performance or something like that. So I want you to think about building portfolio targeted at industries than just like having one type of project that most people have. And then I want to go over some job strategies. So if you're interested in all that stuff, homeworks and such, feel free to kind of sign up for this, and I'll let you know when it's open, probably sometime in September. And these this code and slide is available for free. Download it. Most importantly, try it out. There's this pattern with learning where when I talk and you listen, you only get like about 10 to 15, but when you actually try it out, you get about 45% and 50%. But then when you actually implement it and put it together as part of a whole project, that's when you get to like the next level. So I want you to actually try this out and kind of see if you have any projects, see if you can implement some of these patterns there. So that's how you go about learning it. That's just like the learning cycle, right? Like you want to know what it is, try it, and actually master it for your use case. And general pointers, again, for real work, these are the mental models you need to know: the why, the how, the caveats to look out for. So that's what I try to cover in these in these concepts. The why is critical. The how, the caveats to look out for are also very important. But for lead code or for interviews, go to SQL on lead code, group by hard or sort by hard, and do the top 40. That will pretty much get you through most interviews, especially with SQL. Yeah, do you have any questions with any of the things that we covered? The window functions, CTEs, common analytical patterns. There are some questions. Data vault modeling and SEDs. I do have something on SEDs, not right now on data vault. Thank you, Ravi. Thank you, Muthu. That's great, Ahmed. I'll put something together. Yes, Muthu, I am hoping to do that in Databricks and AWS with Spark. Alejandro, yes, this is all available on GitHub. If you're part of my newsletter, I will send out this recording along with all the links as well. Thank you, Muthu. Chris and Tech, when you say window functions are expensive, what do you mean? Okay. Window functions are expensive. What I mean by expensive is the cost of execution. So let's take a step back, right? When you have any OLAP databases these days, either Snowflake, BigQuery, whatever it might be, they charge based on the amount of data used or the time of execution. For example, for simplicity, let's consider that they charge based on the amount of data you scan, right? Window function scans the entire data set. So if you run window functions on a 10 TB data set, it will scan the entire data set. And that, cost-wise, you are going to be charged a lot by Snowflake. And secondly, the time to execute the window function is going to be long because you're executing you're kind of scanning the entire data set. So that might be kind of a consideration point. And that's what I mean by expensive: cost by vendors charging you, and time. So I hope that helps, Chris. Thanks, Andy. Thanks for joining. I really appreciate your time and kind of taking the time to join here. I don't have any paid office hours, Robert, but just let me know if you have any questions. I'll try to kind of connect with you. I do want to have paid office hours for companies, so yeah, we'll see. But please feel free to reach out. There might be industry to target the healthcare industry as well. Sorry, there might be interest. I'm not sure what you mean, Adam, by that. Hi, Sneha. How are you? Aaron, this was great. I appreciate it. Thank you, Aaron. Thank you for taking the time to join, and hope this actually helps. And please practice it if you want to kind of try it out. Listening is one thing, is great, but you actually get better only if you practice it. I'll stay on for like 5 more minutes. If there are any questions, please let me know. If there are none, thank you everyone for taking the time to join. I really appreciate your time. Please have a good rest of your weekend. Oh, yeah, Amit, I can talk a bit about store procedure. Store procedures are essentially like things you can execute by storing them in your warehouse. So you can so for example, you want to do a series of steps, you save them as a store procedure, and you can execute them when you need to. So it's just like defining certain thing and then executing them whenever you need to. So I mean, we can take a look at Postgres store procedure, right? Thanks, everyone. So I mean, if you look at store procedure, I guess they don't explain the why, but basically you can see that they're creating you're defining a series of actions to be taken within a stored procedure. That's basically it, right? So you're creating insert data, you can give it A and B, and it just inserts into a table. And you can think of it, make it more complex as your thing needs, but it's really difficult because, or not difficult, it's really tricky to maintain because, or debug, because now your things are running in the warehouse database, and how would you trigger it? Those are the type of things you need to understand. Oh, I'm glad it was helpful, Aaron. That's great. Yeah, that project was aimed at kind of showcasing your skills up front. Um, can we say function in Python for store procedure? It is kind of like a function in Python, but it doesn't give you an output. There are functions in databases that are actually functions, right? Like you can give it input, it'll give you output. Store procedures do not give you output. They just execute a series of things. That's the main difference, right? Like even if you see here, so if you take a look at this, right? I don't have any article, but we can look at this. Here, what is it? Functions, you do some computation and give you a value, right? Store procedure can run anything, but it's not really giving you much, if that makes sense. So you can take a look at this. There are nuance differences, but the key idea is I would try to kind of keep the references to store procedures and functions a little on the lower side, because when you define them, you need to understand how they're executed. Debugging them is a little bit tricky. You need to understand where it's defined in your code base. It's a little bit tricky to manage, so I would kind of use them sparingly, if that makes sense. Thank you for joining, everyone. Yeah, I'll stay for another 2 minutes. And yeah, if anyone has any questions, please let me know. Yeah, so window functions, it doesn't get stored. So if you are using, let's say you build a dashboard app, right? Your front end will make a request, and then you will execute a query. A window function can be part of that query. It can be used for analytics in notebooks. It just can be used anywhere your SQL is used. So if you have, for example, DBT, right? You store it in SQL, you can use a window function there. If you have some sort of data pipeline that executes a bunch of SQL query, you can have window functions there. So typically you keep it part of your repository. So I can give you a quick example, right? So if you go to GitHub, I don't know if I have any window function here. So let me see. I might have something here. So here, right, I have it as part this is in Spark, by the way. I have it as part of a code. So it's essentially just a query. You can store it wherever you want to store it, and you can also use it for analytics in a notebook. Think of it as just any other query, right? You do select, I don't know, a star from table. You can store that in a notebook for analytics. You could also use that in your database, in your code base for any purpose you need. And yes, they can be part of view as well. But as I mentioned, a view will get recomputed each time you call it. So you don't want to use window functions that many times unless you absolutely have to. So be careful of the performance. Does that help, Aaron? Thanks, Amit. Have a good weekend. All right. I think those are all the questions. Thank you, everyone, for joining. I really appreciate your time and your attention. TLDR, go through the repository. Please try to practice them if you want to kind of get better at it. And I hope this was helpful. Have a good weekend. And if you like to kind of be be notified about my workshop, please let me know. It'll probably be like pretty intense, a few weekend style workshop. So I hope to see you guys there. There it is. Bye everyone.